Okay, in this video, I want to talk about simplifying rational expressions. So for the first example, we have 16x to the fourth minus 32x to the fourth over 8x squared. Okay, well, how can we simplify this? Well, maybe we could use our factoring techniques to cancel out some terms. So on the bottom, we have 8x squared. So if it's possible, I would like to factor out 8x squared out of the numerator here, and then I could cancel it. And that's what I'm going to try to do now. So 8x squared, and I still have 8x squared in the bottom. What do I need to multiply 8x squared by to get 16x to the fourth? That would be 2x squared. And then 8 times what would equal negative 32? That's negative 4. And then I'm going to need to put another x squared there. All right, now I can just simply cancel that because this will reduce to 1. So my final answer will be 2x squared minus 4x squared. This isn't fully factored, but it is fully simplified. So I can just leave the answer as that. Okay? So I hope that helps. Let's look at this example. We have x squared minus 4 over x minus 2. Is there any way I could factor out x minus 2 from the x squared minus 4? Well, let's see. The top part is definitely difference of squares. X squared minus 4, that's a difference of squares. So I'm going to write that as x plus 2, x minus 2, and that's over x minus 2. X minus 2, x minus 2. Okay, looks like I can reduce that. So the final answer is just going to be x plus 2. All right, well, I hope that helps. Let's look at the next example. I have 4y squared over xy minus 2y. What could I simplify here? It looks like I could probably pull out a y in the denominator. Numerator is pretty simplified already. It's a monomial. So if I factor out a y, I would leave x minus 2. And it does look like I'm able to cancel that y and then cancel that 2. Okay, well, what can I do? It looks like that's it. So it'd just be 4y over x minus 2. Okay. Next example, we have y squared plus 4y over y squared minus 16. Okay, well, the denominator to me definitely looks like a difference of squares. 16 is a square, y squared is a square. The numerator, not so much. It doesn't look like a sum of anything. It looks like we could factor out a y, though. So that's what I'm going to try for the numerator. I'm going to try that. So if I take out a y, I get y plus 4. For the denominator, again, I think this is difference of squares. So that would be y plus 4, y minus 4. Okay. And look, on both top and bottom, I have y plus 4, so I can cancel it. Okay. So I'm going to be left with y over y minus 4. And I'll put parentheses around that to show that that's a single term. That's it. So that's simplified for that one. Let's look at the next example. Okay, I have x squared plus 6x plus 5 over x squared minus 1. Well, the denominator is most certainly a difference of squares. The numerator looks like it's probably a leading coefficient of 1 problem. So for the leading coefficient of 1 problem, or polynomial, I have to find the factors of 5, which add to 6, and I think those would be 5 and 1, right? 5 and 1 multiply to 5 and add to 6, okay? So I think the numerator will be x plus 1, x plus 5. In the denominator, we have x squared minus 1. That is a difference of squares. So I have x plus 1, x minus 1. And look at that. We have x plus 1 on the top and bottom. So I can reduce that. And now we're just left with this. We have x plus 5 as the numerator and x minus 1 as the denominator. So that would be fully simplified. Okay. Again, we can't cross out the x's here because they're separated by addition and subtraction. We can only cancel things out if it's being multiplied. Okay, so be sure that that makes sense to you. All right, next example, we have x squared plus 2x over x squared minus x. Well, they're not leading coefficient of 1 problems, and they're not difference of squares. Looks like we just need to factor out the common terms. So for the top, we could factor out an x. That would leave x plus 2. And for the bottom, I can factor out an x, and that leaves x minus 1. Here, I can cancel out the x right there, and so that leaves me x plus 2 over x minus 1. I'll put parentheses around those. But that's it. That's really all I can do. Again, I can't cancel the x's because they're separated by addition and subtraction. So if it's being multiplied, you can do that, but not if addition and subtraction. All right, for the next example, we have x squared minus 4x plus 4 and x squared minus 3x plus 2. So how can we factor these? Well, we can use leading coefficient of 1 techniques. I think the top one is actually a perfect square. I believe this would be, since 4 is a square, x squared is a square, I think this is going to be x minus 2 quantity squared. So that's what I'm going to try, x minus 2 quantity squared. And for the bottom, I think I'm just going to use leading coefficient of 1. And I need to find the factors of 2, which add to negative 3. Looks like negative 1, negative 2 would add to negative 3 and multiply to 2. So that would leave me x minus 1, x minus 2. Okay, and look at that. I have x minus 2, and I have 2 of them here. So I can cancel the 1 on the bottom and cancel that squared right there. So that leaves me x minus 2, x minus 1. Okay, that's it. Again, I probably should have checked my cross terms for this, which would have been 2 times x, so 2x times negative 2 is negative 4, and that is correct. So this was a perfect square trinomial. Okay, for the next one, it's a little confusing because you have 7 or some constant. In this case, it's 7 over a factor over another factor. So I think for this one, to try to explain what's going on, I'm going to try to just really simplify this. So I'm just going to use kind of a silly example to help with what we should do. So let's say I had 7 over x, okay? You know what? Let's even go simpler. Let's go even simpler. Let's go something like 7 halves divided by 2, okay? Well, what would that be? You can go 7 halves times 1 half, right? Because you're cutting it in half, so you're multiplying it by half, and that's going to be 7/4, okay? So what happened? Did we add these two, or did we multiply these two? Well, we're multiplying these two. So in the end, the only thing that happened was we multiplied these. So let's go back where they were x's. So if this was 7, gotta switch my color back. So if this is 7 over x, what did we find? Oh, well, this equals 7 over x times 1 over x, which just equals 7x squared. Okay. For this one, we ended up just adding the exponents, right? Because we're multiplying. So that's not too bad. Now, when we actually tackle this problem, what can we do to understand? Well, it's 2x plus 9y and 2x plus 9y. So it really is the same thing as those x's. It's just that x was standing for the inside of this whole expression. So we have 7 over 2x plus 9y times 1 over 2x plus 9y to the 7th. Okay, so what are we doing? We're just going to add the exponents. 7 over 2x plus 9y to the 8th. And that's it. That's all you have to do. You just adding the exponents for this particular example. But that can cause a lot of confusion for students. So hopefully that helps. Please write in the comments if it's not helping. Okay, let's take a look at this one. We have q to the third plus 4q squared plus 4q over q cubed plus 2q squared. Yeah, q squared. Now, for the top part, it looks like we're going to have to factor out at least we're going to have to factor out a q. That's for sure, right? That's going to leave q squared plus 4q plus 4. What can I do for the denominator? It looks like I could factor out a q. So I have q squared plus 2. Okay. Now, I can cancel that q right there. Can I factor this top part at all? Yeah, I can factor it. So for the top part, it looks like I can factor, now that I'm looking at it, I should have factored out more on the denominator. I should have factored out q squared. So this would be q plus 2. That looks a lot better. So the greatest common factor was q squared, not just q. So I made a mistake there. So I can cancel out that, and then I'll leave that q there. Now, the numerator looks like a perfect square trinomial to me. So that would be q plus 2 squared. And then we still have that q plus 2. All right. Now, I can cancel this whole term and that whole term. So I have q plus 2 over q. Q plus 2 over q. And that's the final answer, okay? And I can't simplify the q's anymore because this is separated by addition.